Welcome. This is activity 8.4 out of lesson 8. And we've been talking about chemical energy, and we're going to be talking about chemical energy transformations. So earlier in activity 8.1, 8.2, and 8.3, you saw different types of energy transformations. Well, 8.1 and 8.3 were pretty similar. Remember, this is when we had the cupric chloride, then you added aluminum foil to it, and you saw something happen. Then what we did in 8.3 is we manipulated or changed one of the variables. So in the first part of 8.3, we added more aluminum foil. Same amount of cupric chloride, but more aluminum foil. And something different happened. Then we changed it up, and instead of adding aluminum foil, we added steel wool. So we're going to continue to look at energy transformations, and we're going to take a look at some scenarios that you're going to be familiar with, and we're going to see if you can identify the energy transformations. So our learning target today is we will investigate transformations of chemical energy into other energy types. Now, we talk about energy all the time. For example, whether you're running, swimming, exercising, a lot of times when you get done with these activities, you feel run down, you feel tired. And the big question there is, where do you get that energy to do those things? Whether, we talk about energy when it comes to, running a car. Where does a car get its energy from? Where does our body get its energy from? Where do all these different things that we use get their energy from? And that's what we're going to take a look at today. So the first scenario is going to be the engine. So if you look on page 92, and again, it's page 92 this year. If you're doing this activity in a different year and you look at page 92 and it's not activity 8.4, just flip a few pages forward or backwards. You'll find it. The book does change the numbers from year to year, so things aren't always exactly the same, but we're not going to make a new video every single year just because they change the page numbers. So where it says number, put number 1. Where it says phenomenon, just write down engine. So what I'd like you to do is, where it says energy transformations, think about when this car is running, what type of energy transformations are involved? So you've got an engine. What type of energy transformations are involved? So write down as many as you can think of. Then your explanation. There's not a very big box. Just in a sentence or several words or some phrases, just describe that energy transformation. What is it? What's happening? So go ahead, pause the video, and finish the first row for the engine. Now, my question to you is, did you really pause the video? Unfortunately, sometimes students don't pause the video and they keep going forward looking just to write down the answers. Remember, do the right thing, pause the video, and give it a try. Later on, then if the answers are there, you can look and see if you're correct versus just skipping it, going and copying down the answers, because we both know that's not the right thing to do, and that's not how learning best takes place. So go ahead, pause the video, and finish the engine row. All right, so hopefully you've got some information down. Unfortunately, you're not going to see the answer. So make sure you're filling stuff in versus just going through the whole thing and then not having anything. So here we're in row number 2. So write down exercises, the phenomenon. So what type of energy transformations are taking place here? And again, you can use the initials like CE, chemical energy, to KE. So write as many energy transformations as you down that you can see, and then just a brief explanation. Why? Why do you see that? What's happening? Again, I don't know they don't leave you a lot of space, but just do the best you can. So go ahead, pause the video, and finish this row. All right. So watch is going to be phenomenon number 3. So write down number 3. Write down watch. And within the watch, and you can see, there's a battery here, but within this part, what energy transformations are you going to see? And again, write down brief explanations. Again, they don't give you a lot of room. Just do the best you can. Again, make sure you're filling this out. I know I've got some students that won't fill anything out, and they'll just wait and see if the answers are there, and they'll copy it down. Hopefully that's not you. All right, so you can move on to number 4, and number 4 is fireworks. So write down number 4, for the number. The phenomenon is fireworks. What energy transformations do you see here or take place with fireworks? And then write down some brief explanations. So go ahead, pause the video until you get this done. All right, so now we are going to go through what you saw. And again, I'm hoping you have things written down. I know that learning does not take place when you just wait for the answer and you copy everything down. Learning happens when you try, when there's effort. The synapses will fire. In fact, they fire twice. Once before you even know you made a mistake, but when they make a mistake, and then the second time when you realize you made a mistake. So by trying, that's how learning takes place. If you just wait until the answers and copy everything down, learning does not take place, or does not take place very well that way. So when we looked at the car engine, what energy transformations? Well, there's definitely CE going into KE. There's also going to be some thermal energy. Some of you might have said sound energy because you can hear the car running. You can add that to this list as well because you're absolutely right. Are you going to see light energy? Probably not within the engine itself. So what's the explanation? Well, by burning gasoline, the engine transforms CE to TE, which is transformed to kinetic energy of the car. Again, you can start talking about not light energy, but you can talk about the sound energy being created as well. I think that's a really good one to add to this. How about the people exercising? Well, you definitely have chemical energy transformed into kinetic energy. Definitely have thermal energy. Now, here again, you might say sound energy as you're working through. I think that's a good one to have. Is it going to be chemical energy turning right into sound energy? Probably not. Probably going to be chemical energy into kinetic energy, and kinetic energy into sound energy. So again, chemical reactions in your body are creating the energy to move. It's going to create that heat as well. How about the watch? I know they have a quartz watch here, but watch. We're talking, if it's an old-fashioned watch versus a new modern digital watch, that might make a difference. But chemical energy transformed into electrical and kinetic energy. We're going to be getting to electrical energy next. So you may not have had that. You might have said sound energy because you can have alarms on your watches. You might have had light energy because they will light up. I know I've got one where if I press a button, it'll light up so you can, like a backlight, so you can see the digital display. And even ones that had the arms going around it, I've had ones in the past that would light up as well. So chemical energy is transformed into electrical energy in a battery. It is then transformed into kinetic energy in the motor. Now, not all watches have batteries. There are some watches that you have to wind. So if you were thinking of one of those, even though in the picture you saw a battery, you might have like some mechanical energy involved in there as well, or some elastic energy because of the springs that are getting wound up, that are unwinding, which runs the watch. And then the last one, fireworks, you had chemical energy transformed into kinetic, thermal, light, and sound energy. So all those would work. And the chemical reactions transform chemical energy into thermal and light energy. The thermal energy is also transformed into sound energy and kinetic energy, of the shrapnel, of the things that are exploding out of the fireworks. So this is not an all-inclusive list. You might have been thinking of some other things, but we just wanted to expose you to energy transformations. We see them all over the place. So let's turn and let's look at page 93. And again, it's page 93 this year, but it may be a different page as we get different books. So on page 93 this year, making sense question, what is common among all these phenomena? So go ahead, pause the video and answer this. All right, so now that you've played it before, again, I'm hoping that you have an answer, and I'm hoping you're not just waiting and letting it play so you can copy this down, because we both know that's not the right thing to do. And all I can hope is that you did the right thing. But all these phenomena involve chemical energy transformed into other energy types. So if you look at the engine burning gasoline, if you look at your body, at the cellular level, you eat food, you create energy. If you look at the watch, you've got, chemical energy in a battery. And if you look at fireworks, it's definitely a chemical reaction taking place. So the next thing, how does what you've learned about chemical energy help you answer the driving question? Why do some things stop while others keep going? So go ahead, pause the video and answer this question. All right, so again, hopefully you have a good answer here. Well, chemical energy can be transformed into other types of energy, such as kinetic energy, in order to keep things going. When a source of kinetic energy is finished, some things will stop. So we've been exploring why things stop. Well, if you run out of chemical energy, this is another reason why some things may stop. So in today's activity, here are some things to remember. Chemical energy is associated with all matter around us. Chemical reactions can happen at the microscopic level, in other words, the cellular activity when you exercise, or places that are hidden from view, like in a battery, so that we may not notice them. So that is, or does conclude today's activity. Make sure if you have any questions, make sure if you have any things that you don't quite understand, check with your teacher and make sure you ask questions. Thanks.